All right, we're going to be covering discrete probability distributions in these videos. As always, take notes, pause the video often, and complete the problems along with me and the U-tries on your own. In this section, we'll be covering these topics. A random variable, we use the capital letter X usually to denote it, and the random variables that correspond to it as the lowercase letters. So we can have discrete random variables or continuous random variables. Discrete are countable, distinct, different values, and continuous are uncountable values in an interval. We could get like a little bit closer, a little bit closer, a little bit closer. So let's look at this example here. Identify some possible values and which of them are discrete. So a numerical grade a student receives in a course. So if we're kind of talking about like GPA numerical grades, they could get like a 4.0, a 3.1, a 2.2. And these are discrete. They're going to get a set value, a countable value as their final score. But now a grade point average of a student is going to be anywhere between 0 and 4. I mean, we could round a little bit more, a little bit less. You know, it's an uncountable amount of possibilities in between 0 to 4 that a student could get, and so that becomes continuous. Now, the salary of employee defined in figures. So if we're talking about 4 figures, 5 figures, I guess it could be 6 figures, 7 figures, wouldn't that be nice? 8 figures, right? We can count these. These are discrete values that we can count. But the salary of an employee defined in dollars is kind of like any value all the way to infinity, right? Like it could be with cents, it could be whole numbers, right? It's continuous. There's like an uncountable number of options there. So go ahead, give this one a try. Press play when you're ready to see the solution. Now the key component here is we're going to be talking about discrete probability distributions, and these are we're going to use a lot of different probability distributions, but these are our discrete ones. And the key thing here is that the probabilities add up to 1, and the values are between 0 and 1. So we've already kind of covered that in our previous section, but they're going to look a little bit different. A probability distribution can be in a table, which is what this is, or a graph, what we're going to be looking at. So it's also important to note here that these are the exact values. The probability of each of these corresponds exactly. These are the probabilities of rolling a die, a 6-sided die. Each probability is 1 over 6. But a cumulative probability, so notice the difference here, is adding up the previous ones. So remember that the previous one, this was 1/6 and 1/6, so this is now 2/6 because it's adding up all the previous probabilities before. When we graph these, so we'll use decimals. So if we were to divide 1 divided by 6, we would get kind of 0.17. So what they're saying is that our outcomes go on the horizontal axis, our probabilities go on our vertical axis, and then we can kind of just show the probability distribution in that way. So example 2 here. Consider the probability distribution that reflects the number of homes that a realtor sells over a 1-month period. Is this a valid distribution? For it to be a valid distribution, 2 things need to happen. Each probability needs to be between 0 and 1. And if I look here, 0.3, 0.5, 0.1, we're good. And that they have to total up to 1. So let's add those up, 0.3 plus 0.5 plus 1.5 plus 0.5. We do get 1. So yes, it is a valid distribution. Those 2 items are met. What is the probability that the realtor does not sell any houses? So we're going to translate these. So capital X, right? 0. That they sell 0 houses. Well, the probability is 0.30, right? What is the probability that the realtor sells at most 1 house? So that is less than or equal to 1. So that's the probability that they sell 0 and the probability that they sell 1 house. So that's the probability of 0.3 plus 0.5. So the probability of at most 1 house is 0.8. All right, here, what is the probability that they sell at least 2 houses? At least 2 houses. So in this case, greater than or equal to 2 is going to be the probability that they sell 2 plus the probability that they sell 3. So that is 0.15 plus 0.05, so that's 0.2. What is the probability that the realtor sells less than 2 houses? So the probability that the realtor just sells less than 2. So less than 2, the values that are less than 2, that's 0, 1, And it's not 2 because it's not equal to 2, so just 0 and 1. So that's 0.3 plus 0.5. That's 0.8 again. What is the probability that the realtor sells between 0 and 1 houses? So, I'm sorry, 1 and 2 houses. So that means that they sell 1 house or they sell 2 houses. And so that's 0.5 plus 0.15, that's 0.65. Now graphically depict the distribution. So I'm going to do that over here. So the number of houses here could be 0, 1, 2, and 3. These are the houses sold. And our probabilities, they go up to 0.5. So I'm going to do 0.1, 0.2, 0.3, 0.4, and 0.5. So 0 is 0.3, so I'm going to put that bar up there. 1 is 0.5. 0.15 is like 15, right? And 0.05 is kind of right there. And that's the graphical description of this probability distribution. Go ahead and give this one a try and press play when you're ready to see the solution. And there you go. One more example here. So Jane Wormley is a professor of management at a university. She expects to be able to use her grant money to fund up to 2 students for research. Well, she realizes that there is a 5% chance that she may not be able to fund any student. There is an 80% chance that she will be able to fund 2 students. So we've got 5% she may not fund any student. So, and then 80% she'll be able to fund 2. So let's take a peek here. So I like to go vertical with my distributions, X and P of X. So X here is our students, right? Funding students. So she wants to fund up to 2 students. So 0, 1, or 2 students. 5% chance that she may not be able to fund any. So that's 0.05. 80% chance that she'll be able to fund 2 students. So 0.80. We can actually figure this out. We know that they have to add up to 1. So this is going to be 1 minus 0.05 plus 0.8. And so this value here has to be 0.15. So this is the probability distribution. So what is the probability that Jane will fund at most 1 student? So at most 1 student is less than or equal to 1 student. So that's 0 students and 1 student possibility. So that's 0.05 plus 0.15, so that's 0.20. 20% chance that she'll be able to fund at most 1 student. What is the probability that she will fund at least 1 student? Well, that would be 1 student or 2 students, right? Because she's going up to 2. So that's going to be the probability 0.15 plus 0.8. So pretty likely 95% probability that she'll be able to fund at least 1 student. And that concludes this section.